Good evening from a full moon Washington, D.C., late afternoon California, early in Beijing, and wherever else you are, look at your watch. My name is Jennifer Turner, and I'm really excited to welcome you here to our event, Opportunities for Enhanced Near-Term U.S.-China Climate Action. The food system is our theme tonight. This event is co-hosted by the California China Climate Institute at UC Berkeley, a University of California-wide initiative chaired by former Governor Jerry Brown. My project, the China Environment Forum at the Wilson Center, is the other co-sponsor, and I am the director of the China Environment Forum. Before we begin, have a little bit of housekeeping. Do note, this event is being simultaneously translated into Mandarin Chinese. Migrate down to the bottom of your screen and click on the globe and choose the language you want to use. And please don't just leave it in the off setting. Pick a language. This discussion is going to be recorded and later posted on the websites of California China Climate Initiative and the Wilson Center and on our YouTube channels. Throughout the discussion today, feel free anytime to start putting questions in the Q&A, and I'll try to get to them as soon as I can. If you want to put your name and affiliation, that would be great, because I love to see who's out there. Let's get started. So when we think about climate change, the issue of energy and the power sectors comes forefront in people's mind. But in actuality, the food system generates some 34% of greenhouse gas emissions. Like the energy sector, China is also #1 in food system emissions at around 13.5%. The US is third at 8.2%, and Indonesia is in the middle. So a lot of greenhouse gas emissions from the food sector, but the food system also holds a tremendous potential to contribute to climate change solutions, while also helping to meet global food demand and create all kinds of others co-benefits. And those kind of benefits are things that our three speakers tonight are going to talk about. In thinking about US-China action on ag and food, should keep in mind that the two countries have been cooperating for a very long time on agriculture, but it wasn't until the last climate meeting when the US and China signed their Glasgow Declaration that they formally put down that they were going to work together in agriculture. There weren't a lot of details, but it was put down there. And so there's a potential of some kind of opening. And so tonight we're going to be exploring about what do we mean by food greenhouse gas emissions in both the US and China, and what are opportunities for cooperation. Now, I want to highlight that the California China Climate Initiative, along with many partners, has published about 10 papers that link to some of the goals that were in the US-China Climate Declaration. And one of them was written by our leading speaker tonight, Wendy Silver. And in the box, in the chat box, you'll find a link shortly that gives you the link to all of these publications. The Wilson Center last fall launched a US-China Climate Leadership in Food and Agriculture initiative. We've been putting on lots of webinars, trying to create new conversations between government, NGO, scientists, and universities on this topic. And we also are cranking out blogs. And in the summer, we're going to publish a roadmap for US and China in cooperation in this area. But let's get started. Let's get to our speakers. So at this webinar, we have 3 speakers who will explore possible pathways for the US and China to achieve emission reductions in the food and ag sector that promote soil health and meet other kinds of important goals. We're going to start out with Professor Wendy Silver. She's going to be talking about reducing food waste and fertilizer greenhouse gas emissions in the United States. Dr. Silver is a professor of ecosystem ecology and biogeochemistry at UC Berkeley. She has her Silver Lab, where they do a lot of really fascinating research looking at a lot of kind of climate enhanced weather impacts on different ecosystems, from tropical forests to wetlands. And of course, she's doing work on food. Second up is going to be Hu Ming. Hu Ming, I've known you forever. I remember back when she was at the Energy Foundation, she brought groups of Chinese experts to look at emission trading systems in the US. So she was very much focused on the energy sector, has been so for 20 years. But a while back, she created the Institute Innovative Green Development Program, IGDP, as I like to call it. And they're a leading public policy consultancy that focuses exclusively on subnational climate and clean energy action. Tonight, she's going to talk about the China side of reducing food waste and fertilizer greenhouse gas emissions. And then to kind of bring this together in a conversation to look at challenges and opportunities for both these countries to convert food waste to fertilizer in the US and China is Dr. Karen Mansell, who I've been working with for, gosh, Karen, at least 5 years. Sorry, I dropped my phone, forgive me. And Karen is an appropriate person to take on this task. In 2006, she led an ag delegation to China, which kicked off her getting adopted by all kinds of food, soil, and water engineers to work with them on rural challenges with food, wastewater, and soil. So, and she's also working with me on my food and climate project. She's a professor of food, ag, and biological engineering and a water specialist at The Ohio State University, widely published, speaks Chinese. I think we're ready to go. The rules are is that I'm going to have Wendy, if you can put up your slides as I do the final intro here. So each speaker is going to talk for 10 minutes. You can start submitting your questions anytime now. And I'm going to pass the virtual mic over to you, Wendy, and the floor is yours.
Okay, great. You guys can hear me?
We can hear you and we can see your slides.
Okay, excellent. So first of all, I want to thank the organizers for inviting me to speak. And what I'm going to do today is report on a white paper that was recently released that looks at the climate change mitigation potential of a circular nitrogen economy in the food system. And I strongly encourage you to go look at that white paper if you're interested in specific numbers or more detail on any of the issues I'm going to discuss today. Today, what I'm going to do is focus primarily on the US side of that analysis, and others, as you heard, will focus on the China side. Okay, so as you already heard, the food system accounts for over 1/3 of global greenhouse gas emissions, and China and the US are among the leaders in greenhouse gas emissions from the food system globally. Food loss and waste in the food system emits almost a gigaton of CO2 equivalents annually at a global scale, and this is increasing. And so there's opportunity here to look at the reduction of food loss and waste as a way of helping to mitigate greenhouse gas emissions from the food system. In China and the US, food loss and waste accounts for over 10% of food system emissions. And on first glance, that may seem like a low value, but actually this is low-hanging fruit, if you pardon the food pun. This is an area where there is some of the easiest potential to mitigate emissions from a technological perspective, and mitigating these emissions through changing our patterns in food loss and waste have tremendous opportunity for co-benefits that feed back not just on the agricultural enterprise, but also on human and ecosystem health. The US disposes of a lot of food loss and waste, primarily in landfills and through combustion. And that together results in emissions of about 203 million metric tons of CO2 equivalent annually. And to put that in perspective, that's about the same emissions as we get from jet fuel usage on an annual basis in the US. So significant emissions coming from food waste disposal and loss. Those emissions, that food loss and waste also has a lot of embedded nitrogen in it. About 1.6 million metric tons of nitrogen per year are disposed of in food loss and waste. And I have comparable numbers down here for China. And I should caution you that the numbers from China come exclusively from the peer-reviewed literature that we had access to. There may be additional numbers that are available in government reports or other sources that were not in the peer-reviewed literature. So some of these numbers may not be directly comparable, but one of the things that's quite blatant and obvious here is that the nitrogen embedded in food loss and waste in the US is much lower than the nitrogen embedded in food loss and waste in China. And that's because most of the food loss and waste in the US is coming from post-consumer products. So after we've eaten all the nutrient-rich material that is in our food and then disposed of whatever's left over. Whereas in China, most of the food loss and waste nitrogen is coming from the pre-consumer product. And so there's still considerable nitrogen, more nitrogen in that material before it's disposed of. So this food loss and waste nitrogen can be looked at in perspective of how much fertilizer nitrogen we need to add to our crops to have them grow, or how much we're actually adding on an annual basis. Oops, there we go. We add about 13 million metric tons of nitrogen to our crops annually. So food loss and waste accounts for about 12% of the nitrogen that is in chemical fertilizer that we're adding to crops on an annual basis in the US. By throwing away the nitrogen in food loss and waste, we're essentially mining the soil of nutrients and increasing the need for fertilizer nitrogen. And that's important because producing fertilizer nitrogen, chemical fertilizer nitrogen, has a lot of emission consequences. It takes a lot of fossil fuel to actually create chemical nitrogen fertilizer. You have to break apart a very strong divalent bond in nitrogen, and that takes a lot of energy. And so we tend to use natural gas to create chemical fertilizer, chemical nitrogen fertilizer. So that's part of the fertilizer emissions that you see there, 104 million metric tons. And also we use natural gas as one of the substrates or one of the feedstocks for chemical nitrogen fertilizer. So it's a fossil fuel intensive activity. About 40 million metric tons of emissions come from just the production of fertilizer alone. The rest of it comes from field uses of nitrogen fertilizer, and that's primarily due to the production of nitrous oxide. Nitrous oxide is a very potent greenhouse gas. It has a global warming potential that's 298 times higher per molecule than CO2. So that means it's 298 times more potent at warming per molecule than CO2. And the vast majority of nitrous oxide emissions globally come from the food system, primarily from agricultural soils. About 50% in the US of nitrous oxide emissions are coming from agricultural soils. And the vast majority of that is coming from chemical fertilizer usage on those soils. At a national scale, both the US and China are currently adding about twice as much chemical fertilizer as they need. And that may seem surprising to you. This is a graph of data from the FAO that shows nitrogen fertilizer use in million metric tons over time from 1961. And you can see over here on the left in orange that the US has kind of gradually been increasing, maybe leveling off. It peaked in the early 2010s. And in China, it increased until a little bit more recently, the 2010s, and has begun to decline. Why do we add twice as much chemical fertilizer as we need? Well, that's due to a couple of reasons. One is that historically, the low cost and government incentives have led people to add a lot of nitrogen under the mistaken assumption that adding more is going to be better and that we're going to grow more food with it. But actually what ends up happening with that excess nitrogen is that microbes in the soil convert it to nitrous oxide, or it ends up in our waterways where it eutrophies streams and lakes, or it pollutes our drinking water or our groundwater. So excess nitrogen is a bad thing for a lot of different perspectives, and it's not necessary to grow food. We could, at a national level, grow the same amount of food with half the nitrogen usage. Okay, so what's the potential if we were to lower nitrogen fertilizer use and capture the food loss and waste nitrogen that we're currently throwing out into landfills and incinerators? So this is just the US side of the analysis. So right away, we get tremendous savings of about 30 million metric tons of CO2 equivalent just from decreasing the amount of nitrogen fertilizer we add onto soils. We get an additional benefit of about 5 to 10 million metric tons of CO2 equivalent from capturing food loss and waste and then either composting that or putting it through an anaerobic digester, which produces energy in the process, and then using that digestate as a organic fertilizer similar to compost. And overall, at the field scale, we can save about 40 million metric tons of CO2 equivalents on an annual basis, just from decreasing fertilizer use and capturing and reusing that food loss and waste. When you add in the production of fertilizer, of both chemical fertilizer and organic fertilizer from food loss and waste, we get additional savings. So again, if we cut the fertilizer usage by half, we lower the emissions by half. Food loss and waste does result in some emissions, so we need to account for that, and we add that back in. And then overall, our savings at the production scale are about 11 million metric tons. So in the US, without much pain at all from the food production side, and without the need for new technological advances, we could save 51 million metric tons of CO2 equivalent in the US on an annual basis. So just to summarize, that promoting a nitrogen economy is low-hanging fruit right now from a climate mitigation perspective. Food loss and waste represent wasted carbon and nutrients. I focus primarily on the nitrogen story here, but there's a lot of really interesting potential to save carbon as well, both reducing methane emissions and increasing soil carbon sequestration. Capturing and utilizing food loss and waste has the potential to significantly lower greenhouse gas emissions from agriculture, and then also from the waste sector. And again, waste sector emissions were not considered in the analysis I just showed you, but we have 203 million metric tons of CO2 equivalents coming out of landfills and incinerators that could at least partially be mitigated by capturing that waste. And then finally, there are co-benefits, the co-benefits for air and water pollution that I discussed, as well as potential co-benefits of soil carbon sequestration that, again, as a negative carbon technology, could add to the value of this process. And so with that, I will stop. I acknowledge my co-authors and reviewers and hand the mic back to Jennifer. Thank you.
Thank you so much. I really appreciate that. Yeah. Covered a lot of information. I started noting some questions down. I want to remind the audience to start adding questions. I got 2 in so far. Come on, keep bringing them in. So I'll get to the questions at the end. Humin, I'd like to ask you to share your slides. So we're going to switch the story, get a little bit more information about what China is doing.
Can you see it now?
I can see it, and you could.
Thank you very much, Jennifer.
No problem.
I'm
Thank you.
very glad, honored to be on the same panel with Dr. Silver and Dr. Mansell. And thank you, CICC, for organizing this event. Not sure. Okay, great. So I'm very pleased to talk about anything related to US-China collaboration. We had a lot of good history before emission trading and all the climate change work. So this presentation I'm going to make today is based on also a white paper we wrote together with my colleague, Dr. Chen Meian, on food system and climate change in China. So the goal is trying to understand the impact of food system, especially on mitigation potential side of China, of its from a food system perspective. So we just try to look at it from the whole system point of view, from agriculture, production, and the food production, consumption, and also after consumption activities. So the idea is just to have the overall understanding of the scale and the impact in China. So I don't want to talk too much on the global perspective. I think many people already mentioned that. The one thing here I want to highlight is that different countries have a different mitigation structure or emission structure of the agri-food system. So like in China, a large portion of it is from production, and while many other countries might be from consumption and end of after consumption emission, like from the waste management side. So China's agri-food system and climate change. First, it's very important to recognize that we, even though there's no food system concept in China, like people not talking about this term yet, but it's embedded in a lot of high-level national strategies, including the carbon peaking and carbon neutrality strategy that some of us are very familiar with, and also biodiversity protection, and very important public health, food security. All of this, there is national strategy. And most importantly, about the we call it the agriculture sector and the rural development strategy, and China also have this circular economy and zero waste city as a national program. And the new updates from China is that yesterday there is this new institutional reform released from the central government. One of the change will be enhancing the Ministry of Agriculture to be not only covering agriculture, but also rural development. So that said, I think that new or basically enhanced new ministry will be very important policy makers that in future we could try to engage with. So this is the research scope and the methodology. I think, again, if you want to understand it, we can go into, please go to the white paper we have publicized on our website, and it's peer reviewed also. I think the research scope here, you can see just compare with many other existing study, is that we try to cover all the greenhouse gases associated with the food system circle, and we also try to cover many other procedures that we could like from food consumption, farm to table. And the other thing is, I think we try to not only give a baseline scenario, but also do a projection, which I will talk about in the following slides. This is the baseline that we have done for 2019, and this is more or less similar to other studies that they only focus on the emission status. I was trying to calculate how much it's coming from fertilizer and whether it's at the same level as what Dr. Silver just mentioned. I think we will have to have another call or something on that. But I think the fertilizer related emission may be mainly coming from the agriculture production. But if we reduce food waste and some of the measures, end of life measures, we can also reduce fertilizer related emission. That's one. And second, I think for China, the soil quality or the soil health has been always a very important policy, not only for climate change, but also mainly for agriculture sustainability policy. But it's written into China's national determined commitment as one of the main solution or action to mitigate climate change, greenhouse gas emission. So it's called reduce fertilizer consumption in China. But I think at the quantity level, we could have a better understanding of how much impact it is. So China as a huge country with huge population, there are still driving forces that the food system related emission will grow in terms of the fact that the income per capita is still growing, which means people will consume more meat and protein food, and also the per capita animal related food consumption is still quite low compared with other countries. So in order to do our study, we had to review all the policies or the measures embedded, as I just mentioned, into different national strategies that could have an implication of food system greenhouse gas mitigation effect. So there's a list of policies in place already related to promoting agricultural sustainability, in relate to like energy system decarbonization of the food industry, manufacturing industry, processing industry. And the most important one is there's the first comprehensive agriculture climate change action plan issued in June 2022. It's not only the goal is to reduce carbon emission per unit of agriculture production, and also to increase agriculture sequestration ability, carbon sequestration ability. They have mentioned identified several priority areas. These are all very important. So then we try to simplify all these measures into measurable actions, and it's including all these measures we normally talk about in agriculture sector. I will cover it later. And this is the greenhouse gas emission scenarios we have developed, and this is our high-level result. So you can see the reference scenario, meaning if we continue the trend now, is going to continue to grow. And the enhanced action scenario, meaning we implement all the actions in the policy already. In fact, the emission will still grow in future. It's just a plateau, but not decline a lot. The decarbonization scenario, we cover all the actions that's cost effective and also feasible to be implemented in China. So they will have a declining trend, but still not reaching the net zero emission of the whole food system. And this is the baseline. I think I've used too much time. Sorry, Jennifer.
You can take another minute. You're taking a minute. You got it. One more minute.
Okay, sorry. Yes, I will try to jump to the conclusion side here. So we analyzed each measure's mitigation potential, but we basically try to group it into manure management, rice cultivation, fertilizer use reduction, for example, and also agriculture machinery, energy saving and electrification, clean energy in food processing, cooking energy saving, low carbon transport, resource utilization of kitchen waste, plastic reduction, behavior change. So the green bars I want to highlight are the measures that in fact we call it green development measures, which means they are not developed for the purpose of food system greenhouse gas mitigation, but for other sustainability goals that China has already now before the double carbon goals. And enhancing this list of actions will already achieve around 40% mitigation potential under the deep decarbonization scenario in 2050. So we want to highlight this because that's basically, okay, there is no food system strategy, but in fact, there's a lot of measures in China that could achieve food system mitigation. So the green on this chart, the gray color part is what we think we still need to enhance. We call it low carbon agriculture. That means specifically to reduce greenhouse gases in agriculture production sector. That's still the big portion of it. And here you can see the mitigation potential of different measures I just mentioned. I want to highlight that the rice cultivation, in fact, is not the most the largest mitigation measures. In fact, the livestock farming and manure management is very important, and the fertilizer use reduction again is also a very big potential there, and the electrification of cooking and agricultural machinery will be also very important. So energy system in overall the blue part is important. So here we can see the potential in percentage. I still want to highlight the fertilizer part. It's I hope it's 10% overall. I hope it's a similar level as Dr. Silver just mentioned. So several quick recommendations. First, of course, we think it's important to develop an integrated strategy for the agriculture food system. That would be very important to have a coherent policy. And second, database that we always need to know. And third, in fact, we put optimizing the existing green agriculture and clean energy system and circular economy strategy, which China already have developed. We just optimizing this strategy to be more climate friendly will be already very important. And new policy we need are mainly on agricultural machinery, energy saving and electrification, and cooking electrification, and the agriculture production measures. So I will stop here. I finish it. Sorry for using a little bit more time, and I'll be ready for questions later. Thank you.
Just that, because the thing is, you just have to think. I'm going to use a pun. You ready? You want to whet their appetite to go read your report. You could take your slide down, Humin, and no, this report's online now, Humin.
Yes.
Yeah. So this is same thing with Wendy. Wendy could have talked a lot more. She just wanted to get you hungry to read more. All right. So Karen, why don't you pull your slides up, and I'll remind people I've got 7 questions that came in. Please keep adding those questions, and we'll get to as many as we can. Yeah, and also if you have if there's a specific question about a specific panelist, please specify too. All right, Karen, the floor is yours.
All right, 大家好, hello everyone. I'm going to be talking about the challenges and opportunities in food waste to fertilizer. And I want to start with a story. On Christmas Eve in Ohio, 150,000 gallons of waste were spilled onto a neighbor's property. A farmer just north of Columbus, Ohio, was digesting food waste for energy on his farm and storing and spreading that waste as fertilizer. The neighbors were very, very upset when all of this happened. In fact, they'd been complaining for years about the noise, the odors, and the truck traffic of bringing the food waste to the farm for it to be digested. And the state attorney general was starting to seek an injunction to stop the farmer from actually converting food waste to fertilizer. So this particular operation was a company built the digester. So it was a professionally constructed system. And the claim was that they were improperly storing the waste, and it was threatening the public health and safety. And that's why the attorney general was trying to stop them. So let's talk about the ways that food waste is converted to fertilizer. There are 2 different ways to do it. One is through anaerobic digestion to make biogas and fertilizer. And there's a recipe to do this. So the proper recipe to convert food waste to fertilizer is that food waste is organic carbon. And with moisture and heat and excluding air. So here's a tank that's used as an anaerobic digester to keep the air out. And with enough time, you can accomplish this. So the moisture has to be pretty high, 96% water. So it's pretty much liquid. You're going to have a liquid fertilizer when you're finished, and you have to heat this waste up to essentially body temperature so that it will digest. So you have to actually input energy into the system in order for it to digest quickly. If you do it right, you get biogas and liquid fertilizer, and you get it in about 30 days, and it doesn't create any kind of an odor or nuisance. But if you do it wrong, then you generate odors, you produce very little biogas, and it can take months for the waste to stabilize to the point that you can use it as fertilizer. So you have to get the recipe right. The other way to treat this food waste and convert it into fertilizer is by composting it. And the composting process is different. In composting, you have to mix together both carbon and nitrogen in the right ratios and get the moisture right and make sure that you're adding in air. And it takes a certain amount of time to accomplish composting. So here's a composting facility that I visited in China. And here they've mixed together carbon and nitrogen in a ratio of 30 parts carbon to 1 part nitrogen. It's pretty much a solid material. 60% moisture is pretty much like damp soil. And they're incorporating air. And this orange arrow that I have on the slide is pointing to the machine that moves around in this building and stirs the waste in order to make sure that there's air added in. And then, as I said, it takes time. So if you do it right, this compost will heat up to about 150 degrees. And this is really important because at that temperature, it will kill any pathogens, especially plant pathogens that could, spread plant diseases, and it would kill weed seeds. So it's really good to use as a fertilizer. It also will compost in a few weeks if you do everything right. But if you don't do everything right, if you get it wrong, guess what? You create odors, then you start spreading weed seeds and disease and these pathogens. And it also can take months for the compost to stabilize so you can use it as a fertilizer. So there are 3 big challenges to farmers doing this and using food waste as fertilizer. And one is the challenge of time, because they need the fertilizer at planting time, but the food waste is generated every day. Therefore, they have to have storage ponds if it's liquid or storage piles if it's solid, and they have to store this material. And that's where you can start to have odors and issues and the concerns that neighbors might have and because of the time issue. There's also challenges of space. If you go and you buy commercial fertilizer, a bag of commercial chemical fertilizer, it's about 30% nitrogen. But compost or digestate out of an anaerobic digester is only about 1 to 3% nitrogen. So to get the same amount of nitrogen for your crops, you would have to apply 10 times the amount of this material to get the same amount of nutrients as you would from just getting chemical fertilizer. So that, that chemical fertilizer then is the third challenge is this weight. It's pretty lightweight. It's pretty easy to spread it manually or with very small equipment. But especially if it's liquid fertilizer, if it's from digestate, water is extremely heavy and it's not very, the percentage of fertilizer is low. So spreading this fertilizer can become a real challenge in causing soil compaction, and it takes a lot of energy to haul around this very heavy material. So what are the benefits? The benefits of fertilizer, whether it be from chemical fertilizer or from organic fertilizer from food waste, is it increases yield. And that's an initial short-term benefit for the farmer. So farmers need to apply fertilizer to increase their yield for this short-term benefit. But the added benefits of compost or digestate is that they also can improve the soil quality by adding more organic matter into the soil. But that's a long-term benefit. It's not something that's felt immediately, but over years, the soil quality does improve. But there's also co-benefits to society. The greenhouse gas reductions from collecting, treating, and using food waste as fertilizer, or the enhanced landfill capacity where you're not diverting food waste that could be used as fertilizer to a landfill, instead you're recycling it, are benefits to society. So farmers really need to be compensated for these co-benefits to encourage them to take on this practice. Now, China's been way ahead in investing in developing these technologies. China, since the late 70s, has been doing research and development and demonstrations with digesters, and have constructed more than 40 million digesters throughout the countryside. But the United States, our program is much more recent and it's a much smaller scale. We only have a few hundred of these digesters on farms in the United States. China is the leader in the world in producing biogas, but twice the amount of biogas as the United States. We're way down on the list in terms of producing biogas. One of the big things that we have to think about, especially in the United States, is U.S. farmer protection, to protect them from these nuisance lawsuits from their neighbors if they're doing these types of operations. And right now we do have right to farm laws in the United States that protect farmers from nuisance lawsuits if it's normal farming operations. But sadly, food waste to energy type projects, food waste to energy and fertilizer type projects are not considered normal farming operations. So currently they're not protected under most right to farm laws. So the neighbors can complain for years. The Attorney General can seek injunctions in a state like Ohio because this is not a normal farming operation. So in order to encourage this particular practice in the United States, we really need to expand the right to farm to include things like waste to energy and fertilizer practices, so that this would be encouraged and take advantage of this very valuable resource. So to learn more about my work at the Ohio State University and the Soil Environment Technology and Learning Lab, you can go to my website, the Soil Environment Technology Learning Lab, where we don't treat soil like dirt. Thank you.
I should have unmuted myself because I always laugh when you say that, Karen. Don't treat soil like dirt. Yeah, so thank you so much. I think we're going to expand out and get to see everyone here again. And I'm going to start pulling some questions up from the audience. And before I do, I should also note in the background, managing things, that we've got Jennifer Perron and Jessica Gordon, who helped, we worked together to put together this panel. So saluting you in the background there, ladies. All right, ready to ask some questions? Speakers, you ready? You may not. All right. So first question from Lily Brumell. Why does China have fewer FWL? So that's food waste loss. Why does China have fewer FWL disposal emissions, but more nitrogen embedded in it?
Right. So I can answer that one. That's
Okay.
because most of the food waste and food loss and waste in China comes from pre-consumer products. So it's got a higher nitrogen concentration. In the US, most of the food loss and waste is post-consumer. So think about a nice, not a nice, I'm a vegetarian, but let's say you're eating a steak and it's got a lot of protein in it, which means it has a lot of embedded nitrogen in it. But so you've eaten most of the steak itself and you're throwing away the bone and maybe a little bit of fat. So that's going into the food waste system, but it's much, much lower nitrogen than the meat itself. In China, a higher proportion of food loss and waste is coming pre-consumer. So there are products, including crop products, corn, wheat, grains, that have higher nitrogen concentrations before people have had a chance to eat them. And so that's why there's more nitrogen, even though there's a lower total amount of per capita waste.
Okay.
Agreed.
You agree? Okay. So,
Yes, agreed. And there's another question about on the percentage of So in 2019, I forgot the ADAGA data, but our data shows because so first of all, our data is direct emission, so we did not talk about the embedded emission. So the direct emission in 2019, around 59% coming from agricultural production, and around half of it, a little bit less than half of it, coming from nitrogen N2O emission. So that's around 25 to 30%. I don't have the number in my hand, but that's about the level related to fertilizer.
Actually, I know we got a lot of questions, but I want to ask one question for all of you to kind of answer, because something that came up, because Karen gave us this great understanding of fertilizer and, well, the fertilizer question that that all of you have said. I mean, Humin and Dr. Silver said at the beginning that there's a big potential to lower the amounts of fertilizer that we're putting on. And Humin, you said that the Chinese government has this as one of their policies.
Yep.
First of all, again, I know you said there were incentives, but why is it so difficult to do something that seems like so common sense to me? You're putting on too much and you'd save money by doing less. Why don't we start? I'm going to start with Humin. What could, just a little bit more like why it's happening and what do you think could be done to reduce over fertilizer application in China?
Well, I think first of all, we probably need to recognize that fertilizer reduction is probably one of the main measures that China is taking to reduce agriculture greenhouse gas emission. And so when we say, if we look at the mitigation potential, the fertilizer related is 10% in 2050, because it's already, well implemented measures already. There's not much more China can do on fertilizer reduction itself, but there's other behavior change. For example, you change the way of the diet system, the structure, or reduce the food waste. That could reduce the the overall agriculture production related mitigation emission. And I think the for the challenge, Dr. Mansell Karen already listed many of the factors, which is same in China. And I think the other one is that in China we have a very limited of land availability compared with many other countries. That also makes it quite challenging. We want to keep the yield level and without using chemical fertilizer, sometimes is quite challenging. I hope this.
Yeah, that's good. And Wendy, anything you want to add about maybe on the US side?
I would just add that, in the US, there's been a history of incentive programs. Some of those have come from the government. Some of those have come from seed producers who also often are and middlemen, middlewomen who also sell fertilizer. And so, and also instructions to farmers. Some of those come from our extension system and are based just historically on assuming that if you add more nitrogen fertilizer, you'll get more growth. But there's plenty of really sound scientific research in the peer-reviewed literature that shows that you don't need that, and in fact, it's detrimental. So it's something that we could use more help in spreading the word. I think it'll save money. It'll save a lot of emissions, but also other environmental hazards that come from this. And then I think that there was some important issues raised with the challenges of using alternative fertilizers. And I think we tend to think of fertilizer only going, or compost and digestate only going on to row crops, but certainly grassland systems are a good place to use some of that material in the off season and could really benefit. And we've shown that carbon sequestration rates are actually higher in those systems than they are in the row crop systems. So you could keep this going, going year round in many systems. Yeah, I think that, but the easiest thing that we could do right off the bat is just decrease the amount of nitrogen fertilizer use. And there are some US programs underway that are also trying to think this through and come up with better strategies to support farmers to apply less inorganic chemical fertilizer.
All right, Karen, my ag outreach expert here. So you,
Well,
again,
I guess-
you really painted a good picture about some of the challenges of compost and other ways.
Well, the biggest thing is the risk. The farmer's paycheck comes from the crops that they grow and they can sell. So if they sacrifice yield in any way, they're cutting their paycheck. And nitrogen actually doesn't cost very much. So you want to make sure that you apply enough so that you don't hurt your yield, because nitrogen has probably the biggest impact on yield of just about any practice that they can undertake. And they know this from experience, because when fertilizer was first introduced in China in the 80s, they just saw huge impact of yield gains by applying fertilizer. So they learned through practice that if they apply nitrogen fertilizer, they get more yield. And if they apply more, they get more yield. So it gets to the point of diminishing returns, but you want to make sure that you apply enough so that you don't risk sacrificing yield. So the Fertilizer Institute and quite a few number of environmental organizations and the farm bureaus are starting to look at the 4R nutrient stewardship program as a way to educate farmers about managing their fertilizer use. And the 4R stand for the right time, the right place, the right form, and the right amount of fertilizer. So this, a particular approach to thinking about how to best apply fertilizer. So, and this has to be customized. The soil type, the crop type, the type of farming operation, you're going to have to use different practices. So we do need to have agricultural professionals to advise farmers on how best to fertilize so that they maintain yield, not sacrifice yield, but also don't create environmental harm.
And I have to, in doing this project that we started at the Wilson Center, because I've been digging deeper into this topic, and I've been seeing that, like in the United States, that there's a growing, there's more investment coming from the Biden administration into climate friendly ag, but there's also these kind of networks of businesses and NGOs and universities that are also coming together, and we're going to be hopefully over the next few months featuring more of these kinds of groups that are trying to work in ways that it still benefits the farmers. It's because the bottom line is, as Karen tells me a lot, there has to be a market. The farmers in the US, we respond to the market. And all right, I'll switch back to some of the questions here, and speakers, you can also kind of see some of the questions coming in here. There's one from Zhenzhong Si. Does the Chinese government provide any subsidies for reusing food waste on the farm, such as subsidizing biogas digesters? How are those subsidies distributed? Do the majority of small producers have equal access to those subsidies? Thanks.
Thank you. It's a good question. As Karen just mentioned, China already basically started very early time to promote the digester of household in the rural area. Yes, there is subsidies, and there is, I think it's not very high. And there's the access is always good. I don't see there a huge problem of that. I think on that, the digesters nowadays, the problem is to me is more not only on subsidies. So there are two kinds of subsidy. One is on the digester, but the other one is on the biomass utilization from the energy perspective. So to me, the barrier now is not mainly on subsidies, but also on the how to say it's the small digester. The scattered digester is not very convenient. It's very labor intensive somehow, if there are so many small digesters, but how to make it more like a community level. Some of the cases we have visited in village, to make it more community level rather than household level somehow could be a better way in China. And I also want, if I may, Jennifer, I want to pick up the other question about, there's a question about the small farmers going to agriculture business level farms. That question, I think it's very interesting and very important. So I think there's I want to repeat the question because I think it's a good question to so maybe it's already deleted.
And no, it got moved to answer because I think.
Okay, perfect.
But
that's great because I think that another fact is that the per household or per farm land is in the US is 20 times of the China per farm land coverage. So it's a different level, different story. So for Chinese, making them bigger will improve the productivity and energy efficiency. At the same time, it might have problem causing fertilizer related emission, but we need to find the best balance on that.
Can I add to that?
please.
So that the digester program began at the Biogas Institute in Chengdu in the late 70s. And one of the parts of the recipe to digest waste anaerobically is temperature. You have to heat the digester up. Well, for anyone who's been to Chengdu, it's a very warm place. And so the digesters work wonderfully in South China because they work year round. They're easy to keep warm enough, and they produce biogas. They have enough gas on a typical farm to run a stove, to cook 3 meals a day and have additional gas, maybe for lighting or for other types of uses. But when you move to northern China, even just as far north as Shandong, which is not even that far north, winter comes along and temperatures drop and biogas production goes way down when these digesters are not heated. So when you get to North China, these individual digesters don't work year round. So that's where the community scale digesters that have supplemental heating make the most sense. So I've published one paper on with some colleagues in China on this analysis, where the individual digesters work really, really well on these small farms in southern China. But when you get to northern China, where you have to heat them in the wintertime, that's where there's a different type of approach to treating the waste and keeping it running year round. Also, one of the things with the subsidy is the subsidy varies based on the wealth of the province. So the subsidies are lower in East China for digesters, and as you move west, you get into the poorer provinces, the subsidies are higher. So they do even have differential subsidies based on the level of income or poverty in different regions. So the application of digesters is not one size fits all in a country as vast as China, also as vast as the United States. You have to have different designs based on the environmental conditions.
Thank you very much. You guys are giving good answers. And I want you to think about, before we leave, I'm going to see if you guys have any questions for each other. But I want to ping one. Someone had asked a question about whether or not any of you had data on these kinds of issues for India and Indonesia, which I don't know if you do, but it reminded me that data. I mean, I remember when, looking at on greenhouse gas emissions in the energy sector, that's always been kind of a wrestling match for years, like getting the right data so you could do the right models and understand who's emitting what. Do we have data problems in ag emission world? We'll start with Wendy.
Yeah, absolutely. Yeah, this is a hard thing to measure. And you can measure some things from space-based approaches, which give us, reasonable measurements of some agricultural activity. But for greenhouse gas emissions, and particularly nitrous oxide and methane, the two most important greenhouse gases in agricultural systems, we can't. And there's a lot of the kind of standard approach is I have to say this, my colleagues would hate me, but it's wholly inadequate. We're moving to very expensive but much more effective automated systems that are showing that some agricultural systems, fertilized corn, for example, may have 25 to 50% more emissions than we previously thought, because we were missing the hot moments, the short periods of time when we would get bursts of greenhouse gas emissions out of the soil. My lab is now working with engineers to develop new sensors, new low-cost sensors that are printable. You can print them off of inkjet printers or silk screening type printers that would be able to give us the opportunity to help farmers instrument in a much larger sphere and be able to use their cell phones to record data. And that, of course, is incredibly valuable for scientists, but it would also be incredibly valuable for managers to be able to say, oh, let's not irrigate in the back 40 today because it's emitting nitrous oxide. And the irrigation or fertilizer could potentially increase that nitrous oxide emission. So we're on the cusp of some, I think, really big technological breakthroughs for data. Obviously, space-based approaches would be fabulous, but we're not there yet for these gases. And so we're dependent upon these labor-intensive or expensive approaches.
I mean, space-based ones, I could see that working in the US with our big fields, but those tiny little postage stamps fields in China might be a little harder. Karen, what about you?
I would just say really quick that for some measures with space-based approaches now, we can get within centimeters.
Oh, dang.
So,
Okay.
So
I
the technology really is improving quickly.
Karen, anything to say about data?
So I have visited with some of the scientists and engineers with USDA who are doing some of these measurements, and still it's quite expensive and quite complicated the in-field practices. So we're kind of relying on, we've done these experiments. If you do this particular treatment, you can expect this kind of reduction, and then passing that on to farmers, but not actually field proving and measuring everything in the field, just because it's so difficult and so expensive to do it.
But we also need that measurement, though, because there's talk about how, China has been as a big advocate, as Humi mentioned, about wanting like carbon sequestration in farms.
Yes.
And it's like, how do we measure and verify?
Right.
And so that farmers can do the carbon credit. That's kind of a sexy thing these days. They're talking about that all over, and even in China. And my first question is, how are we going to measure it?
Right.
Anything to add on that, Humi?
Yes, so on that, absolutely, it's very important to measure and verify it. There is a lot of debating around that. And I think overall it's good to channel more financing and support into agriculture reduction. So it's important. Verifying, of course, makes it a level market. The other thing on data and measurement is important is even to measure the effectiveness of the mitigation measures on reducing fertilizer. The key word in China is, we call it 测土配方, is testing the soil testing and fertilizer recommendation. But imagine there is a huge number of it's over 200 million household or farms in China. And if we want every farm could afford this kind of technology, and we can also measure the effectiveness of the technology, we really need to have a lot of database and a good monitoring and verification technology in place.
Thank you. So quick, do you guys have a question for each other? I gave you.
Yeah, can I ask a question to Karen, because she has done a lot of and Also to Dr. Silver too about the digester. It is a big program, a huge program in China for a long time. As you said, starting from Sichuan, and even when President Xi working in Shanxi province, he was one of the policymaker promoting this technology. But somehow inside China, there's this discussions thinking that could be a technology not fitting in the current situation in China already. And what do you know, like in this new modern time somehow. So is it it's two ways. One is about the food waste and the agricultural waste utilization at a small scale. And the other way is the big scale biomass, mass and bioenergy utilization. How do you see this the evolution of this technology in future in China or around the world, basically?
Well, I worked in a digester lab when I was in college, and I was analyzing the waste for the operation, and that was in the 70s. And what was happening in the 70s? We had the oil embargo, and gas prices went crazy. So there was all of a sudden a big interest in doing research on energy. And in the 70s also, China was experiencing some of the same things. So they started this Biogas Institute in Chengdu. So, I had a job and I was working in this lab, and all of my colleagues were doing this type of work, and we were publishing papers. And by the mid-80s, the oil embargo was over, the energy crisis was gone, and in the United States, our research on biogas went down to nothing. There was nothing published on it. All the labs shut down. We moved on, but China kept going. They kept doing research. So their research is so far ahead of the United States because they started the Research Institute in 79, and it's continued through all of these years. So if I'm really looking for expertise in this area, that's where I look, because they've continued to do research on anaerobic digestion on all scales, everything from the individual small digesters to the thousands and thousands of mid-size and large digesters that are also built on farming operations, which I've visited throughout China. So especially in the north, because like I said, you have to heat them in the north. So that's where you'll see most of the adoption of the large digesters. The small digester program just really didn't take off in the north. So if you go to, large egg farms around Beijing, you'll see these digesters.
I wanted to ask you, jump in there, Karen, because I know that we've been a lot of time, we're talking today a lot about crops, but did have a question from Jeremy Glenn about the percentage of greenhouse gas emissions from the livestock industry. And we do know that in the last few years, we've been seeing more animal feeding operations in China to actually starting to use anaerobic digestion of the waste, because back when I first started at the Wilson Center, I'm sorry, that animal waste was going right into the rivers. I mean, it was like there was 3 times more pig waste, solid waste, than there was solid waste from all of China's industry. And now they are using it. There's like industrial scale biogas, right. And that's a good news story, right?
It's a good news story, indeed. And that's what you're seeing at on all these large livestock operations that I visited. They all have these. And the photograph that I showed, that was from a large swine operation that I visited in China.
And I know that IGDP is going to be, dare I say, digging more into manure in the coming years as well, in terms of a greenhouse gas reducing potential.
I have a question for Huming.
Can I weigh in really quick?
Oh, yeah.
Digester issue.
Sure.
I just want to say that there is some movement in the US, and particularly in California, where I'm based, on digesters. And California has been trying to incentivize the use of digesters, particularly in dairy systems, because manure waste is such a big emitter. We're the largest dairy state in the country and a big beef cow producer, and one of the biggest animal agriculture regions in the world, as well as one of the biggest emitters from that. And so there's tremendous potential to capture that in biodigestion. And there's several cities, including Boston, and some of the Midwest cities that are starting to build large biodigesters for urban waste and food waste, with the idea of potentially even in using human waste, and then probably not land applying that in cropping systems for human consumption, but for in grasslands and other regions where there's animal feed grown. So there, even though there's some nice research showing that that material can actually be safe to apply to soils that are growing human food. So I think that there's movement. I do think that we're quite a ways behind. Some other countries also quite a ways behind Europe with regard to that, but there's this movement in that direction. So I'm hoping that we'll get there eventually.
And we could talk to our Chinese colleagues to get some hints probably. Karen, you had a question?
One of the big drivers for agricultural policy in rural China is poverty alleviation.
Mm-hmm.
Bringing especially rural residents out of poverty. So how does poverty alleviation policies impact the implementation of reduction of greenhouse gases in the ag sector? Is it complementary or is it conflicting? Is one conflict with the other, the poverty alleviation policies versus the greenhouse gas reduction policies?
Mm-hmm. Great question, Karen. I don't think it's contradicting right now. So before was so one of the poverty alleviation policy is mainly to give more job opportunities to the farmers, which might not be inside the agriculture sector. And now there is this trend that the farmers go to the cities to work, and now there's another trend we have observed that there are young people, going back to the rural area, and the new time for the rural development in China is to so-called modernization of the rural area. So which means higher the higher electrification use consumption, and for agriculture sector, there will be more, as some of the audience already observed, you can see the small farms merged into bigger farms so that it could be more agriculture business size of farms. This kind of trend, somehow, one way you see higher energy efficiency level, and second, you can see higher energy consumption, total energy consumption. And at the same time, the production efficiency might be higher, even though we're using more fertilizer, probably, but the efficiency might be higher. So it takes a lot of measurement and analysis to understand it, but overall, we cannot stop it. That's the trend. People want a better life, and the modernization of the rural area. So I think the answer will be, how can we capitalize this trend to make it more, constructive, or to not to lock into a long-term high carbon footprint of agriculture sector in China. So how can we get the infrastructure done? For example, we talk about digesters. Is there any more efficient and like community size digester, which might be easier for people to use and low maintenance? All of this question need to be answered, and that's the opportunity, I hope. Thank you.
No, thanks. That it's a good way to end it, because it's also, Karen, you remind us that we got to think about the farmers, and that the policies need to be designed in ways that make their lives easier, create the correct incentives that again give them livelihood, and if we can measure it, lower of greenhouse gas emissions. We've hit the end of our time, and I'm sorry we didn't get to all of the questions, but we're making note of them, because I don't know. I mean, California China Climate we're going to continue having these kinds of conversations. So me late at night, you guys late afternoon, early morning Beijing. It's going to be fun. But I'll also be having, I learned a lot from the questions that are asked, and there were some that we didn't have time for, asking about questions about what about consumer behavior. We'll get to that, but I think that it's, yeah, we don't have time. But it's just like, but there's excellent questions, and I want to thank all three of you for sharing your smarts tonight with all of us. And want to thank all the people, Jessica and Jennifer in the background, and all of our interpreters. Thumbs up to them. And have a good night or good morning wherever you're hanging your hat. Bye-bye.